I'm Thomas Abbott. I'm a master's student at McGill, and I work with CHIME and with Caspi. And today I'll be talking about our FRB alerts from the CHIME telescope. And I'll also be describing some alert services that can apply to any FRB detecting observatory. So before I begin, we saw already yesterday a lot of motivation to do follow-up and to do counterpart searches for FRBs. But I wanted to motivate specifically why we should do rapid follow-up of these events. And one in particular, arguably the most informative observation we've made yet, is this galactic magnetar. And so there's no reason to believe that such an event couldn't happen again at any time. And so we should be ready for that. We should have infrastructure in place that automates the alert of the detection as well as the follow-up of such an event. And we've also learned a tremendous amount from hyperactive repeaters. We were able to study perform statistical studies of their burst properties, which is really unique. And those sources aren't active forever. We also have to be quick with how we're able to follow those up and to ensure we can collect as many bursts as possible, and also to be on source for the early stages of that activity period. And some examples so far, SGR 1935, we've seen a lot about, and a few hyperactive repeaters, which in this case have been shared through the Astronomer's Telegram. And so I'll be talking mostly about the CHIME alerts today. So we've already seen a little bit about CHIME, but just to highlight four important aspects, it has a very large field of view. It scans the entire northern sky, or pretty much the entire northern sky every night. And it has a pretty good sensitivity and very powerful data processing pipeline that allows it to detect thousands of FRBs to date. And so if you're setting up an FRB alert service, this is an excellent candidate to start. It's basically an FRB detecting machine. And so I've been a little bit vague so far about FRB alert service. So just to get into a little bit more detail about what specific information we're sharing and how that will be done. We have virtual observatory events. So this was work started by Emily Petrov, who defined a standard virtual observatory event format specifically for fast radio bursts. And to oversimplify a little bit, they come in four source types: detection, which is essentially a one-off source, it's a newly detected FRB; subsequent, which is a source, a detection, from a known FRB source, so basically a repeater; and then a retraction is just a recall of a false positive event. And update allows for some flexibility if we have, for instance, updated burst property measurements. And so the VO event itself includes two sections, one describing the host observatory and its FRB pipeline, and then one describing the FRB itself, things like time of arrival, dispersion measurements, and everything else. So in terms of actually implementing such an alert service at CHIME, this was work started by Andrew Zwaniga, who was a master's student at McGill. And this was the CHIME FRB VO event service. It became public in October of 2021. And since then has broadcast 2,159 VO events. So we see a breakdown of what those events look like over here. So 1,700 detection or one-off events, and 340 or so repeat bursts. So though this data is not up to par with the catalogs we published, this is arguably the largest collection of FRBs available to the public. So it's a really valuable service, hopefully, to the community. So in terms of detection stats, we send out about 2 alerts per day. And the latency from when the FRB reaches our telescope to when that alert arrives in your inbox or at your API is between 10 and 15 seconds. So just before I move on from that, I just want to talk about some of the community engagement, which has been really fantastic with the CHIME FRB VO event service. So we have 115 subscribing groups that consists of all different levels of academic stages, from undergraduate to faculty, also independent researchers from a dozen countries in 4 continents. So that's been really exciting to see that engagement. We have, arguably the most impactful thing that this service has done is brought latency of FRB follow-up down from days or weeks to just a matter of seconds. And that's enabled a lot of interesting follow-up campaigns. One that I wanted to highlight was one from the Swift Bat Observatory. They've been doing follow-up of several of our events and really working hard to reduce the amount of time it takes from them, from our detections to go out to when they're on source. And I believe the last event they followed up was done in less than 2 minutes. So that's from when the FRB arrives at our observatory to when their observatory is pointing on source is under 2 minutes, which is really incredible work on our side. We also had the first video event triggered localization of an FRB, and that was done by Professor Vikram Rambi et al. Using DSA. And we've also had awesome engagement from some folks at Astronomy who've been following up our subsequent events. So this information is available online just on our public website. If you Google Chime FRB, this will be the first thing to pop up. We have links to subscribe to the service as well as the public database of all the video events we broadcast. Now again, this is not something I would recommend for doing any sort of population study. It's just a reference. It could be a fun way to get involved with the data if you want to do some outreach, or maybe you're teaching a class and would like to get your students involved with FRB data. This could be a nice way to do it. There's just a JSON file you can download and start to play around with. We're soon automating the TNS naming of our events, so we hope to include the TNS name in the video event, which will hopefully simplify follow-up and make that easier to communicate. Okay, so far I've been describing Chime FRB video events, but we've also been working on developing essentially the same video event service, but one that's telescope agnostic, so any FRB detecting observatory can host their own video events. And that's done through the software package FRB VOE, which is completely open source and available for download on GitHub. It has hopefully a pretty easy installation. And basically one of the goals of this software is just to validate the data to ensure that all the alerts sent out from this package are following the VO event standard, and so that subscribers that are receiving these alerts can use the same scripts to parse and process the alerts as they would from Chime or other telescopes. Okay, there's a lot of, in my opinion, very exciting opportunities with multiple FRB detecting observatories producing their own alerts. So one example that comes to mind is that we could see in real time co-detections potentially across different bandwidths. We could really play the strengths of each observatory. So Chime, for instance, a great FRB detecting machine, could detect an active repeater, and then another telescope such as the DSA could localize that repeater and make that information public, and then a telescope like FAST could sit on source and detect 1 million bursts from it. So there's a lot of potentials for coordinating FRB follow-up within radio observatories, and also as we saw from SWIFT and other observatories, there's potential for high energy and multi-messenger follow-up. Okay, and then something that's been discussed a little bit is integration into larger transient networks or databases, and that's something we're working on. So for example, NASA GCNs is streamlining their service a little bit. They're now planning on releasing just JSON files for all transients, and they're also encouraging members of different wavelengths or messengers to get their alerts involved in GCNs. And so we've done that. We've developed an FRB schema for NASA GCN so that any FRB detecting observatory can easily get involved in that. That's something we plan to get set up soon with Chime. So we'll have Chime FRB GCNs coming soon. And then just to mention, the VO event service itself will remain as it was before, online and operating. This will just be an alternative to reach a bit of a broader transient community. Okay, and then I'll just add some links in case you'd like to have a look at the software, and I'll stop there. Thank you.
Thanks, Thomas. Thanks for keeping even a little bit under time. So we have plenty of time for questions.
How many observatories have the VO event system implemented? Is it just Chime right now, or?
Yeah, so well, VO events themselves have been used for other transient events, but for FRB VO events, so far it's just been Chime. I think other observatories have internal events, but publicly available. It's just Chime. Yeah.
How soon is soon on the Kafka?
That's a good question. I don't know the answer because it also depends on the NASA GCN team. So I've heard like Actually, in a few months. I'm not exactly sure.
It would be very useful for the gravitational wave follow-up because we're limited by the grid transport.
Hi, yeah, just give us
That's
2
good.
minutes. We're just finishing the previous talk, sorry.
Oh,
We can hear you though.
yeah.
Thanks.
This is great. Do you include the probability sky maps in the view event, and do you plan to in the GCM?
Yeah, so in the view event, we have a localization, which is, yeah, so actually, our real-time localizations are not great. This is what they typically look like, and that's a problem if we're trying to do alerts that are simple and easy to adjust, right? Because we have, for instance, we have different islands where the event could exist, and so that's not totally, that doesn't follow the standard of many of these transient alerts. And so typically what we do right now is we focus in on the central island and just scale up the uncertainty a little bit. And that's what we provide in our alerts, which is not great. We do have better localizations, but the challenge is those usually require additional processing. And there are a lot of issues that could happen with networking or data transfer. And so if we want to have a rapid, reliable alert, this is our best option for localizations. And that localization, that same localization will also be in the GCM.
It would be nice to provide them in the same format as LDK, for example.
Yeah, I guess that's something I could discuss with the GCM to do.
We'll see it'll be a lot better once the outriggers are operational.
Yeah, I mean, the localizations are excellent. The issue is getting that data public quickly is very, very challenging.
Just one final question. We have a talk tomorrow about this also, but do you know what the lag time will be? Like how long it would take if you have the outriggers going to have a localization?
Well, so I'm not part of the outriggers team, so I don't know if I'm.
Manuel's going to be here tomorrow. He'll talk more about it.
I mean, I think that they can get localizations in a few hours, but I don't know if that's going to be. Well, there are no plans to make those public right away, at least right now.
So that's going to be internal to the Chime team for follow-up.
For now, yeah.
But the alerts will be sent, right?
Yeah,
Because these are the events, a subset of these events will be localized neutrinos.
Yes, but those outrigger localizations.
Localizations will not be public.
Yeah,
You know
maybe.
which event.
I mean, so far what we've done, if we see a really interesting event, we get a better localization and send that through the astronomer's telegram. But view events themselves are just quick and dirty real-time localizations.
So they won't be secret, but they won't be released.
Right, yeah, I think.
Localizations won't be released through the field.
Yeah, like,
Okay.
so there was this recent potential association with gravitational wave and FRB, and I think it was detected at Chime at like 6 a.m., and then we had 50 people on a call by 9 a.m., so there's a lot of interest in getting this information out there, but it's just that view events is maybe not the venue for those.
Okay, let's thank Tom